In this video, we are going to talk about outliers. Outliers. But first, we need to understand what exactly an outlier is. Put simply, an outlier is a number in a dataset that is way different from the rest. It is either much higher or much lower than all of the other values. I always think of it like one person in a class who may bring the average way up or way down by getting either an unusually high score or an unusually low score. So in this example, let's say most of your class scores are between 80 and 90, but one person scores a 30. So this 30 here, this is an outlier. This is an outlier because it does not fit in with the rest of the data points. Okay, now that we have a general idea for what an outlier is, let's find a mathematical definition for what makes an outlier an outlier. I like to call what we're about to do the 1.5 method. 1.5 method. So there are three steps in this method, I should say. One is to calculate the interquartile range. IQR. IQR. So let's do that, right? So here we have the median, which is going to be Q2. And then that makes our quartile 1 and quartile 3, 6 and 12. And if you're not familiar with this, I encourage you to go watch my video over interquartile range. But if not, we will continue. So our interquartile range here is going to be 12 minus 6, which gives us 6. And then step 2 is going to be to multiply our interquartile range by 1.5. So 1.5 times 6. And then what we are going to do from there, let's call this value x. And what we're going to do from there is take quartile 1, subtract x from this, and then we're going to take quartile 3 and add x to this. So let's see. 1.5 times 6 is going to give us 9. So quartile 1 is 6 minus 9 is equal to -3. And then quartile 3 is 12 plus 9 is going to give us 21. 21. Now right here, 12 plus 9 is equal to 21. And what this actually does is give us a range of numbers. So we're going to have from a -3 to 21. -3 to 21. So this gives the range of all of the data points that are not outliers. So step 3 is to see which data points up here do not lie in this range. And in this case, that is only 30 because we see -4 here is the smallest number and it's greater than -3. And then 12 is less than 21. But 30 here is greater than our maximum value here. So 30 is an outlier. 30 is an outlier. Let's try calculating whether any of these numbers are outliers once again. Alright, so our first step is to find the interquartile range, which we can do. So we know here that 15 is quartile 2. So that makes 12 and 13. And once again, if we have two numbers as a quartile, what we're going to do is find the average of these numbers. So 12 and 13, their average is going to be 12.5. 12.5. And then here, same thing for 17 and 18, their average would be 17.5. 17.5. Okay, this is going to be 17.5 minus 12.5, which gives us 5. So this is our interquartile range. So now what we are going to do is multiply this interquartile range by 1.5. So this is going to give us 7.5, and I'll write that here. 5, sorry, I'll write that in a different color. 5 times 1.5. And this gives us 7.5. 7.5. And now we're going to subtract this from the lower quartile. So 12.5 minus 7.5. And then comma. We're going to add this from our quartile 3, which is going to be 17.5 plus 7.5. So let's figure out what these are. Let's see. 12.5 minus 7.5. Well, we can just say 12 minus 7, which gives us 5. And I'll write this range in white. So 5 to, let's see, we can just make this 18 plus 7, which would give us 25. 25. So our range of all numbers that are not outliers are going to be 5 to 25. So let's start from the lowest. Our lowest number here is 8, which is in this range. So there's no outliers that are below the range of the non-outliers, but there is a number up here that is. So in this case, 28 is an outlier, and it appears to be our only outlier. So 28 is an outlier. Now what I'm going to do is kind of prove to you the importance of finding outliers in a data set. So what we're going to do in this case is actually find two means. We're going to find the mean of the data set from 12 to 18 here, and then the median of the data set from 12 to 40. So let's go ahead and plot all of these points, which I will go ahead and do. And I will plot these in white. So this is going to be 12, 14. We have two 15s here. A 16. A 17. 18, and we'll say 40 for later. Okay, now that I've plotted these, we could go ahead and calculate the the mean, which would be all of these numbers summed and then divided by 7, which you could do if you wanted to, but I put this in a calculator and we get 15.3. 15.3. So our mean here would be plotted by the point, and I'm not going to plot it down here, I'll point it up here. This would kind of be right here, which you'll notice this is pretty accurate, right? So the mean is kind of the center value where all of the points have a different pull depending on how far away. So this right here gives us an accurate center point for all of these data points. So if we were to add 40 into the data set, however, if we were to add 40, this would change the mean pretty drastically, which you will see. So if we were to sum all of these up and then divide by 8, because once again there are 8 data points instead of 7, we would get 18.4, 18.4, which would move our mean all the way about here, about there, which moves our mean, that would be 3.1 in the positive direction. And now you can see the importance of finding an outlier, right? So if we were to find an accurate center point for all of these data points, this right here shows a much more accurate center than 40, because 40 is kind of pulling on the mean, because the farther away you are from the mean, the more pull it has. So if we were to have 100, as an outlier, the mean would be probably around here somewhere. So you can see the importance of finding outliers in a data set, because they significantly change the statistics of a data set. And we are done.